Hi everyone, welcome to this advanced steel tutorial looking at the single-sided end plate connection. So today I'm using Autodesk Advanced Steel 2019 and I'm going to launch the connection vault from my home ribbon. And what I want to look at today is connecting the tie beam back to the column on my main structure. You'll see on the platform beams we have a range of different connections. And on platform we have a command called single-sided end plate. You'll see that the selection order is beam and then the beam to connect, and it's any profile and it will connect the two beams together. So I've made this a favorite, it's on my favorites tab. So I'm going to select my single-sided end plate. So it's first of all asking to select the main beam, so this will be the column. Then I right click, then select the tie beam, and it will launch with this configuration. So like most connections, we have properties, libraries and joint design. And if we start looking at this connection, so this connection will do a single-sided end plate, but it will also notch the beams together. So if this is coming in to meet the web, you will see by the screen it will notch the beam. In this instance I'm coming flush into the web of the column, so there's no need for a notch. I will come to the notch once I put a connection between my tie beam at my rafter. So let's look at this end plate first of all. So first of all, I go to plates and bolts. I can specify the plate thickness, I can specify an erection tolerance, which will shift it out. And if we look at the bolts and holes, what I'm going to do first of all is set my diameter, and I'm going to keep it with an XOX bolt. The grade and assembly are standard. I have a little button to invert the bolts if I wish, and also the ability to slot the holes in both the plate and the column. Again, I'm just going to set that to none because I want to concentrate on getting the size and position of the end plate. So the size and position of the end plate is controlled by the bolt positions. So when we look at the horizontal bolts, plate set out is the first thing we should look at. Currently it's setting it out based upon the bolt edge. What that means is as the bolt moves, this will control the end of the plate. So if I set the distance to 150, that will adjust the width of the plate, including an edge distance projection. So if I change this back to a total, it allows me to enter a value manually. So I can just set a total width. So I can go 575. So I can do that, and then I can change the center distance of the bolts, and they will work accordingly. But what I'm going to work with is the projection. So this will take the projection of the tie beam, and then I can set the values either side. So I want that flush to be both sides. So I want this plate to be the same width as the tie beam, and that will give me 88.7. Or if I want, I can just go to total and set it to 100 and a center distance of, let's say, 60. So that gets the position width right. So I'm going to go with 160 mil center distance. And the number of bolts per side, if I set it to 2, will double up, but in this instance I just want 2 bolts a side. We then look at the vertical bolts, and again it's the same principles for how we set out the plate. Now currently it's set out by section. We can change that to middle, so it will set it out from the middle, and then you've got these values for set out distances top and bottom. So currently middle distance, and the length is controlled by the distance from the top bolt. So what you can do there is if you can set it out 50 from the top, 50 from the bottom, there you get your end plate. And then what you do is you control the distance in between, and as we control the distances of 75, you can see that in the bolt group 75 between, we've got a 50 mil distance from the center of the bolt to the top of the plate, and the same from the bottom. You can go through these various different options. So you can go total from the top, and then you set out your distances, and we could say 150, and it will control it that way. But the one I want to work with is bolt distance from the top. Let's say that is going to be 30 and 30, and that will set it out like that. And if we go with the 75 spacing, and let's increase this back to 50 and 50. So it's just a matter of going through and setting these options. So it's just understanding that the bolts are really controlling the size of the plate, we have options for stiffeners, so I could stiffener on the top, bottom, both, but in this instance just in the position of where I'm at it's not really going to work, so I'm going to set that to none. And we also have the ability to stiffen the beam, so I can put a stiffener in both sides. Again, I can just right click, advanced joint properties, so in this instance I'm going to put that pretty standard end plate into position. Now if we concentrate on this one, where it'll get a little bit more complex, so it's a single sided end plate, select my rafter, right click and select the tie beam. And when we have a look at this, you will see that it's now started to auto notch the tie beam going in, and this is because we have the notch properties. So in the other example there was no notch. In here I can actually control how this notches round beam, so I can notch the main beam, and I can top detail where I can auto notch it, or I can actually manually start to do it and where the notch is orientating from. So I tend to leave mine on auto notch at all times, and then I just control how it's setting out the object. So if you can see there, it currently says that it's set out from the flange. And what that means is that when it's set to from flange, this distance just controls the distance between the notch and the flange. So if I set it to 10, that's a good clearance for me, and then you have the same for the notch on the underside. So I'll just orbit this round slightly. So in here we also have it's coming from the inside of the flange. We can go outside and you'll see that the notch will go up, and we could set it down 30 millimeters, or I can tend to go inside of the main, which will be the distance on the inside of the flange, and again I set that to 10, and that gets me my notch detail. So once we get to the notch, it's then the same principle where we set the distance for the holes, and then we look at the horizontal plate. You can see it's coming from the bolt edge. I'm going to set the distance to 60, 0 projection, 0 projection. If you wanted that go to be a total, we would just go 100. So it's a 100 wide plate, 60 mil between the bolt centers. We then look at the vertical bolts, and we can actually go plate from a section, and it's the total distance from the top, and you'll see that's got a set out distance of minus 30. If that was set to 0, the plate would be flush with the top. So if I just go, let's say minus 30 or minus 24, you'll see that I can start moving the plate up and down. So if we go with something like that, where it's say minus 23, we then control the distance between the bolts. So let's say the distance was 60 millimeters and we had a 50 mil at the top, and that gives you a plate length then of 140. So let's have a look. We've got both added, end there to there, and we are good to go. So join me again soon where I will look at copying the joints across this building model.